one where you have multiple intervals that are solutions to your inequality. So it's either everything that's lower than some value or everything that's greater than another value. Right? And so if you're looking at a problem kind of modeled in this format, you'll actually see the expression or the term or included in the problem itself. And then it's just a matter of, again, by hand, you're just going to solve each part individually. Okay, so if you're looking to solve one of these double unbounded inequalities, just take the left one and solve it. So subtract a 1 from both sides, leaving a 3x is less than or equal to 9. Isolate your x completely by dividing by 3. That gives you x is less than or equal to 3. So here's one of your intervals. Or your other interval, just do the same thing. Solve the other part completely by itself. 4x is greater than 20. Undo the operation, so isolate your x by dividing by 4. And so this would be your inequality notation. Right? If you were going to write this, yeah. Only if you multiply or divide by a negative.
By a negative? Oh, yeah. Okay. I thought it was studying.
Oh, no. So only if you, so again, when you add or subtract, nothing happens to the inequality. The only time the inequality gets flipped is if you multiply or divide by a negative value. Okay. So once you have this whole set, that's your answer. And if you were entering this online, you would enter it x less than equal to 3. Or x is greater than 5. Yeah. Well, what I'll do is you'll see that I'll put the or in it myself. Always start with the lowest value to the left. Okay? Anytime you're writing inequalities, always start with you're thinking of it just like a number line. The lower values go to the left, the higher values go to the right. Now, if you wanted to write this in the interval notation, which is more likely what I'll do on a quiz or a test, okay, now this is the kind that has that union of sets symbol, that U in between the two, okay, because these are two unbounded intervals. Okay, so this is x is less than or equal to 3, so it goes from negative infinity all the way up to 3. Does it include 3? Does it have the equal to in it? Yeah, so it's a bracket at 3. The infinities can never be included, so it's always going to be a parentheses, whether it's a positive or negative infinity. And then the second interval, x is greater than 5, is 5 the minimal point or the maximum point? X is greater than 5. It's the minimum point, so it extends from 5 all the way to positive infinity. You can never include infinity. You are not including the 5 here either, so it's a parentheses. And then when you have multiple intervals in a solution set, you need to use the U. The U represents union of sets. It just means that there's more than one set or interval within the solution set itself. And now, do you guys think your calculators will solve this for you? They're pretty powerful. Yeah. Okay, so really you could solve your double unbounded inequalities using your calculator also. Okay, so if I hit the algebra F2 algebra tab, choose solve, type in my inequality exactly as it appears, including the space and the or, it'll calculate this for me. So if I take 3x plus 1 is less than or equal to, remember I can use the shortcut of the green diamond and then less than, gives me less than or equal to 10. Now I'm going to need a space, the word or, and then another space. So I'm going to alpha lock this. Remember my space key is right down here, the change of sign key, so space. Type in the word or, space again. I can deselect the alpha lock key to finish my expression. 4x minus 1 is greater than 19. Comma x tells the calculator what I want it to solve for. And now when I hit enter, it gives me my solution. X is greater than 5 or x is less than or equal to 3. Now again, notice that even if I gave you, or even if you use your calculator here, if this is the form, so this is the inequality form, okay, I would expect you to put the lower value here and the upper value here. So I would expect you to take what your calculator gives you, move the 3 to the left, the 5 to the right when you write those out. Same is true in the interval notation. It has to go from left to right. Negative infinity is the lowest, then 3, then 5, and then positive infinity. It needs to go from least to greatest. Once again, you can use your calculators for this. If you're not getting the solution with your calculator for the bounded interval, you're more than welcome to ask me. I'll check and see if you have the most updated operating system, and I can explain how you can go about getting that. Okay, so let's take a look at this example. Here, if you solve it by hand, we look to isolate the variable in each inequality separately. So subtract a 3 from both sides. Divide by 2, we get x is equal to, or x is less than 2. Or do the same thing to isolate your variable. Add 2 to both sides, x is greater than or equal to 6. So here is our inequality form. The 2 is to the left of 6, so it does go in the same order that these numbers appear on a number line. And so now it's just a matter of interpreting this into the interval notation. We have 2 intervals. So again, you're thinking 2 intervals here. And now I've just put grouping symbols here. I'm going to change them to what I need it to be. But this is the general form for this OR compound inequality. So my lower limit is this interval. It goes from all the values that are less than 2. So is 2 an upper or lower limit to that interval itself? It's the upper limit. So 2 here, so that means that negative infinity is my unbounded lower limit. Is 2 included in my set? No, so I can leave this as a parenthesis. Now my union of set symbols tells me there's another interval that's part of the solution set in this problem. So here it's x is greater than or equal to 6. So is 6 my upper or lower limit for that interval? X is greater than, so 6 is my lower limit. It extends all the way to infinity. Always a parenthesis at infinity. And what do you notice about this? It has the equal to, so is this a parenthesis here? No, it's going to be a bracket. And so this would be the interval notation for that solution.